Hello everyone, this is grade 6, module 5, lesson 8, problem set. The directions for number 1 state, plot the points for each shape, determine the area of the polygon, and then write an expression that could be used to determine the area of the figure. Explain how each part of the expression corresponds to the situation. So the first thing we want to do is plot all these points in. I'm going to zoom in here so I can see them, and so you can as well. So I'm going to plot these and label them with the letters. So my first one is 1, 3. So I'm always going to start right at the origin, which is right here where the X and Y meet. I want to make sure that that's my starting point every time. And when I look at my points, the first one, 1, is on the X, 3 is the Y. So it's X then Y, meaning I'm going to go side to side, because the X is the horizontal, and then the Y is vertical. So I'll go horizontally first, then vertically next. So 1, 3. So I'm going to start at the origin, go over 1, and up 3, and I'm going to put a red dot there, and label that A. My next one for B is 2, 8, so I'll go over 2, and then 1, 2, 3, 4, 5, 6, 7, 8. C is 8, 8. So 1, 2, 3, 4, 5, 6, 7, 8. And up here, it's a terrible dot or point, but it'll work. Then 10, 3. And lastly, 5, negative 2. So this is the first one that's not going to be in the first quadrant, because the negative for the Y means I'm going down, and the positive 5 means I'm going to start on the X, go to the right. So I'll count over 5, and then I'm going to go down 2, which is going to put me right about there. So that's E. Now I want to do is connect this to create my polygon. So there's my figure there. It's a pentagon. And now what I need to do is try to find the area of this. And it's a little challenging, but I'm going to break it into a few different triangles here to help me out. And I see I can make a couple of them in here. So let me break them apart into triangles. So there's my first line, and I got a triangle down below here. I'm going to label that as my triangle 1. And then I'm going to draw another line in here to try to help out with breaking this top trapezoid into 2 more triangles. So there's my other one that's going from A to C, and now I have 3 triangles. So the first thing I want to do is now find the area of these. And I see that I have a straight line, and I have to have some straight line to catch measurements off of. So this first one going across here that I drew, I want to get the measurement of that, and I can count 1, 2, 3, 4, 5, 6, 7, 8, 9. So that measurement is 9, and I can use that for triangles 1 and 2. Now I'll start with triangle 1, and now I got to find the height of it, and I'm going to come to E, and I'm going to draw a perpendicular line, meaning a straight line that's going to come down and form a 90-degree angle with that red line that I drew right here. And I'll do this in blue. So I'm going to go from E down, and I got 1, 2, 3, 4, 5. So, and I'm going to label it 1. I know I'm using 1/2 base height. So I'm going to have 1/2, and my base is 9, and my height is 5. So that's for triangle 1. I'll get all the dimensions set, and then we can work through the different calculations. So let's look at 2. I know that I'm going to use the same formula because I'm working with triangles. And I know that I can call my base 9 still, because I'm still going to use this straight line that I made. Now I got to find the height. So I'm going to go to the peak point of triangle 2, which is C, and I'm going to come straight down to form a 90-degree angle or perpendicular line segments with my 9, which is my base. So I'm going to count that. And I got 1, 2, 3, 4, 5. And it looks like it's the same exact measurement as my first triangle. So once I calculate 1, the first triangle, I automatically have it for the second because it's the same dimensions. So now I'm going to look at 3. And again, I got my 1/2 base times height. And now I got to figure out my base and height. So my first thing is I'm going to look for the base, which is this straight line from B to C. And I'll count that. I got 1, 2, 3, 4, 5, 6. So that's my base. And then I'm going to count my height. And I'm coming from the top point of A down to B. So I'm going to draw a little dotted line going out from B, just so I know where to hit to, and I'm going to go from A, because here's my highest point of triangle 3. So I have 1, 2, 3, 4, 5. Now that I have the dimensions of my 3 triangles, I can find their areas. So I'll do 2 down below, and 2 will give me the answer to 1 because they're both 9 and 5 here. So I'm going to combine my 2 numbers and get 45. And I got to take half of 45. Or divide it by 2. And it's going to end up with 22 and 5/10. And these are units squared. And I'm going to abbreviate with U to the second power. Now, if you can't do 45 or take half of 45 in your head, you can show that out by dividing by 2. And I know if this is 22 and a half or 22 and 5/10, I know that this one is 22 and 5/10 units squared because they have the same base and height for it. They might not necessarily be the same shape, which they aren't. They're both triangles, but they don't look like the same triangle. But since the dimensions are the same, the area is going to be the same. So I don't even have to calculate that one out. Now my other one, I have half of 6 times 5, which is 30. And I know half of 30 is 15. And again, it's units squared. So I have my 3 triangles that make up my pentagon. Now, all I have to do is add those up. So if I add those all up, I'm going to end up with 60. And that's going to be units squared. And the reason why I did 45 is I know that 22 and a half and 22 and a half is 45. So the expression that I'm going to be looking for here, there's a couple of different pieces we can use for this expression. I like to take right at my substitution for each of these. So the expression that I'm going to do is I'm going to take anything that I bracketed in black here, and I know that I got to add all those up because that's what I did up here. Is I added triangle 1, 2, and 3 together to get this. So I'm going to take this piece, the formula piece, and say 1/2 of 9 times 5 plus 1/2 of 9 times 5. So I did this triangle and this triangle, and now I'm going to add in 1 plus 1/2 of 6 times 5. And if it helps to bracket these off, we don't need brackets. I feel like it helps me, even though they're not necessary, because I can say this is triangle 1, and I'll draw a triangle for that. Triangle 2 and triangle 3. So there's my expression right there. Some of you might just put down 22 and 5/10 plus 22 and 5/10 plus 15. That's good, but we're trying to figure out how did we get to this 15, and right here, this point, 1/2 times 6 times 5 is really what the expression is, because it's showing us how we get all of these answers using the formula. So that was a really in-depth question. Let's take a look over at slide 2, or page 2 of the homework. So page 2 is going to be similar to this. We're going to plot the 3 shapes, and then I'm going to look at 4 pretty much, because the area of a triangle using a different method. So I'm going to zoom in here, and I'm going to plot in E, F, and G. So there are my points right there, E, F, and G, and now I want to connect them to make my triangle. So there's my triangle, and the first thing I might consider doing if I'm going to do this the first way is I'm going to break it into 2 by drawing a line and cutting this, and then I can find triangle 1 and triangle 2 right there. But this is saying an alternative way, and that's maybe what you do for 3. For question 3 up here is to find it breaking it into this, because now I got a straight line to find my base and height out of. But what I want to do is show you the other way, and the other way is to form a rectangle using the 3 vertices around here. So I'm going to touch F on the outside of my rectangle, and then I'm going to touch E on the outside, and lastly I want to make sure G is touching the outside. So I've formed a rectangle around my triangle. So now I can find the area of the rectangle using length times width, and I see that I have 1, 2, 3, 4, 5, 6, 7, 8, and then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So my area is 96 units squared, and that's for the rectangle. So that's the whole place. Now I can go through and I can find the area of this triangle, and this triangle. And once I find those 3 areas, I can subtract it from this 96. And that's going to give me the leftover piece, which is our triangle that we drew in the middle. That's an alternative way to do it. So I'd find the area of this using 1, 2, 3, 4, and 12, or not 12, 4 and 10, because those are my dimensions. And I have to use A equals 1/2 base times height. And then I can find my dimensions here of 1, 2, 3, 4. And this one is 12. And then this one down below is 2 by 1, 2, 3, 4, 5, 6, 7, 8. So I got my dimensions here that I can find area, and then I'd subtract it from 96. And that's an alternative method to breaking the triangle into other triangles and finding the area of it. So you have 2 different strategies you could use for this one. Hope this helps. Thanks for watching, and good luck on your problem set.